Hello everyone, my name is Valentin and I'm here to present on my project AI Chess Grandmaster, a chess-focused large language model that I fine-tuned to be both an engaging tutor and competent chess opponent. This project leverages cutting-edge AI to help users learn and play chess no matter their skill level. Let me share a bit about my background. I began my career in computational chemistry. I was a researcher, but now I'm on the path of becoming a machine learning engineer. So, project description. Can a large language model learn to play chess? So, in this project, instead of moving pieces on the chessboard, we write the moves in what's called standard algebraic notation. So for example, here we have the classic Scotch game. This can be written as the sequence of moves e4, e5, knight f3, knight c6, and d4. So we want a model to be able to understand and read these inputs and predict the next best move. So the model I've created here is a Gemma fine-tuned 2 billion parameter model. And so for example here, when we ask it to predict the next move in the sequence e4, e5, knight f3, knight c6, the response given here by Gemma is d4. So here we're entering the Scotch game. This project also showcases the use of large language models in being able to teach chess and act as a chess tutor. So in this example here, we asked Gemini what's a good first move in chess. It replies with e4 and d4 and even gives an explanation as to why. So onto the model itself. So I built an application, has two components. The first component here is the chess mastery. So there's the model that you play against on the chessboard. So this is a Gemma 2 billion parameter model, and it was fine-tuned using LoRa. This was on the Google Cloud platform on a data set of over 10,000 online chess games. And so LoRa is really great here because it allows us to only optimize just a few parameters here in the A and B decomposition matrices, and then we keep the pre-trained weights frozen, so it's very efficient. And I've provided here the learning rate, weight decay, and rank that I use, as well as the cross entropy loss and accuracy after fine-tuning. So the second component of the application is the chess knowledge model, which is a Gemma 2B instruct-tuned model where we use retrieval augmented generation, or RAG, to add context from chess articles to the prompt based on the user's question. For example, when a user asks, how does the knight move in chess? We query the wiki database and find the article related to knights and their movement in chess. And we add that as context to the full prompt. And Gemma then responds with only the relevant and accurate information to the user. So here's a quick demo of the application, which is hosted on Hugging Face Spaces. So we got the chessboard and also the chatbot interface. And so the idea here is you're not allowed to click and move the pieces. Instead, you have to type out the moves in algebraic notation. So here I played e4, and then the Gemma model takes some time to make its move. Here it decides to play e6. So this is for more advanced players if you want to get straight to playing against the model. For newer players, the chatbot interface offers the tutor and the learning services here. So we can ask Gemini what's a good first move, recommends e4, the king pawn opening, and d4, queen's pawn opening. So this is kind of the two models in one application. And also for more advanced players, I've also added a chess openings explorer. So that's the end of the project. If you would like to learn more, please visit my profiles on GitHub, Hugging Face, or my LinkedIn. The model card is also hosted on Kaggle, and I've written a Medium article as well summarizing my results and my process. Big shout out to my advisor, David Ramirez, and team members And then a big thank you to Kaggle, KaggleX, and Google for providing their resources. Thank you.